Hello everyone, my name is Santosh Kumar. Today I am presenting a project on financial forecasting frontier distributed machine learning for banking analytics. So this is capstone project in banking terms. So dataset of bank marketing dataset is 4521 records with 17 attributes. Tech stack of that: Hadoop, IDFS concept, Hive, SQL warehouse, Apache Spark, Spark MLlib, Spark structured streaming. The overview of project is: bank generate enormous volumes of customer transactional and campaign data every day. Making sense of this data quickly and at scale is what separates a bank that reacts to problem from one that anticipates them. This project is built to an end-to-end distributed data pipeline on top of real-world bank telemarketing dataset. The classic bank marketing dataset simulating how a modern banking data platform would store and query large volume of customer data using a Hadoop IDFS style distributed file system with Hive style SQL warehouse implemented here with Spark SQL catalog and managed tables. Explore the data at scale using Apache Spark. Predict whether the customer will subscribe to term deposit using Spark MLlib. Distributed machine learning. Process transaction in real time using Spark structured streaming. Demonstrate data parallelism, showing how fascinating affects processing throughout the distributed data. Note on environment. This notebook runs top to bottom on Google Colab. So these are the objectives. So objective first are data storage and querying, Hadoop Hive simulation. This is the first part. Second is EDA, exploratory data analysis with Spark. Third is predictive modeling with Spark ML. Fourth is real-time transaction processing with Spark streaming. Fifth is data parallelism. So this is the dataset dictionary: age, job, material, education, default, balance, etc. So this is my project banner for financial forecasting frontier. Also I have given the GitHub link of this file. This is the GitHub link of financial forecasting. Environment setup. All dependencies are satisfied if I run the code. Second is import and imports with Spark session. I have imported the libraries. Import NumPy as NP, Pandas as PD, Matplotlib, PyPlot as PLT, Seaborn as SNS, and so on. So it shows the Spark version after running the code. Spark version 4.0.3. Spark user interface running in local mode with 2 cores. Data storage and querying with Hadoop Hive. So store the raw banking dataset in distributed file system style layout and query it using Hive style SQL exactly as bank's data engineering. So firstly we have import the data, bank.csv, that is bank.csv file. So it is after running the code, it is showing saving bank.csv dataset ready, and it's showing I have run load the raw data into distributed data frame. So this is the dataset. After I have loaded the dataset, I have run the code, and total records found in this dataset 4521. Number of partitions simulated blocks are 8. Age, job, that age is integer, job is string type, metal is string also, education are string, default string, balance integer, housing are string. So it has defined the value with integer type and string also, string and integer. Register as Hive style managed table plus temporary view, run Hive query language. So I have run the code, and it have shows the tables views available in default namespace. Table name as with bank managed bank data. Age, job, age 55, 47, 57, 52, 32, and job type retired, management, admin, technician, and management. Marital, married or single. So secondary, this is showing the data set. Only showing top 5 rows. So I have selected the 5 rows for that. Style analytics queries. So average balance subscription count by job role. Select a job. So it is the SQL query. Round average balance with count as average balance, count as customer, some case when y yes, then else 0 to end. So if the case is true, then it's showing the yes, and if no else part, so it is showing the 0. From bank data, group by job, order by average balance. So this is the query 1, and query 2 I have run the query. So it is showing the average balance and subscription count by job role. So this is the retired. Average balance are 2319, and customers 230, and 54 subscribers. So this is also blue collar job, unemployed, admin. This is showing all. So I have made the chart for that, and I have run the code average balance by job. So it is showing, after running the code, it is showing average account balance by job role, Hive safety query. So this is the retired household. So this many type of job it is showing by graph. It is showing that retired are mostly account balance by job role. So this is the chart. Second chart are, subscription rate, term deposit subscription rate by education level. So this is the showing the education level. Territory have the most subscription rate. Term deposit subscription rate are 14 something, and secondary have 10 plus, and unknown have also 10 something, and primary have 8 plus. So second part is ADA, exploratory data analysis with Spark. So objective of this Spark distributed engine aggregate the simulated dataset, then visualize the result, uncover customer behavior patterns, trends, anomalies, exactly what bank analytics team would do before building a predictive model. So we have run the query bank df.group by y count.show. So it is showing the summary, age, balance, duration, yes count and no count. So if yes, it is 521 and no have 4000 value. So this is the target class balance, because we have 4521 values total. Target class distribution, we have made the pie chart for that. So 11.5% have yes and 88.5% no. Age distribution, we have made the code and run the code after the customer age distribution that is showing by the graph. Account balance distribution, have this chart showing. We have made many charts of in customer count by job type, age type. So these are also chart. Next chart for customer count by job type, and this is the pie chart for marital status distribution. So this is the showing divorced have 11.7%, 26.5% single, and married have 61.9%. This is huge data for married. So by next for education level counts, customer count by education level. So this is the customer count by education level, secondary, tertiary, primary, and unknown. So number of customers are secondary type are maximum. This is the maximum type of secondary education level, then territory, then primary, then unknown. Housing loan versus subscription outcome. So this is the shows the housing loan versus term deposit subscription. So no have the brown red values and yes have green values. So this is the number of customers has housing loan or not. This is the personal loan versus term deposit subscription. No have also brown red values and yes have green values. So next is content communication type, cellular, unknown contact type, and telephone. So cellular contact type have the most customer, number of customer are maximum, that are 3000 something. In these values, unknown have these values, and telephone have minimum values. That has cellular, not landline telephones. So cellular have maximum. So it's campaign contact volumes by month. Next is correlation heat map. Heat map for numeric features. So this is showing the diagonal 1 1 1 2 age, balance, day, duration and campaign, so on. So this is the heat map. Account balance by subscription outcome. This is the also this graph. Account balance by subscription outcome. No and yes values. Next is last contract duration by subscription outcome. So this is the new type of graph I have generated. No and yes. Yes have green values, no have brown values, red brown values. So next chart is previous campaign outcome versus current subscription. So no have red values also and green have yes values. Failure, other, success and unknown. So unknown have the maximum values subscribed. Campaign outcome. Age versus balance scatter colored by subscription outcome. So this is the dot chart for that. Part third is predictive modeling with Spark ML. So we have built the Spark ML pre-processing modeling pipeline. We have run the code and model performance comparison. So this is the AUC value and accuracy with F1 values. So this is the score for green and blue values. Green has logistic regression and green has random forest values and blue has logistic regression values. Confusion matrix we have also made for the random forest. So this is the blue values predicted with 100 and no have yes have 100 values and no have 771 values. So this is the confusion matrix predicted. We have made also ROC curve random forest. So this is the bow type of random forest. So top 15 features importance of random forest. So this is the chart for that. Next is real-time transaction analysis with Spark streaming. So this is the lengthy project for me. Real-time transaction analysis with Spark streaming. So we have made the code and run the code. This is chart for live streaming aggregation transaction processed by job finance with final snapshot. So this is the blue collar job have the maximum. then the management, then technician. This is the value. Cumulative transaction processed across streaming batches. This is the curve. Efficient data handling through data parallelism. So this is the chart for data parallelism. Query execution time or say degree of data parallelism. So 1, 2, 4, 8 and 16 values. This is the execution time. Number of partition. So maximum partition are 16. So this is go to 1 to 2, 2 to 4, 4 to 8, 8 to 16. We have made the clean shutdown for that. So in this product challenge optimization and trade-offs of my cluster setup and on a notebook environment, streaming without Kafka and categorical feature explosion, small data parallelism overhead and class imbalance. So roughly 88% of customers did not subscribe when notes accuracy upward for free. This is why AUC and F1 were tracked alongside accuracy rather than relying accuracy alone. So learning and practical value of this distributed engine, like Spark, let the same code scale from a laptop to 1000 node cluster. Hive style SQL over the data lake gives analyst a familiar interface while the underlying execution stays fully distributed and parallel. Structure streaming on files, batches and streaming code. So future improvement for that, this is future improvement. I write that, and after that this is conclusion for this project. This notebook demonstrated a complete end-to-end distributed data banking analytics. So thanks for watching.